I would like to thank you for coming today, and I would like to thank the speakers for spending time to prepare the presentations and be with us today and inform us of what is happening in the area of energy and food. And I would like also to thank the collaborators of the Centre for the support and the funding they provided today. So what I'm going to do is, in this talk, is to give you a bit of background on the Centre and describe the process we have made, on the progress we have made over the last 2 years, and highlight some of the opportunities that there are for collaboration moving into the future. Now, as you heard from Catherine, the CSEF is one of the 6 end-use energy demand centres that were established by RCUK to look at energy demand reduction across the various sectors of the economy. The mission of the centre is to carry out, first of all, research that has impacts in the short term, working with key stakeholders to achieve quick results, because industry, as we heard earlier, is very interested in having payback periods of 2 or 3 years, and therefore really it's important for us to be able to understand the issues, understand the problems along the food chain, and be able to contribute to that, and also to satisfy the remit of RCUK, carry out more fundamental research that will have impacts over the longer term and contribute towards achieving the target of 80% emissions reductions by 2050 compared to 1990 level. And of course, the third objective of the centre is to establish a centre as a key player in this sphere of energy and food nationally and internationally. Now, the centre is a collaboration between 3 university groups. Brunel University, that is the lead, and I'm the director. Then we have Manchester University, and the co-investigator there, or co-director, is Professor Savvas Tassou, who's sitting over there. And then we have Birmingham, that the principal investigator there is Professor Peter Fryer, but is represented today by Professor Ian Norton, who's sitting at the back there. And we have amongst the audience today about 40 researchers working in the centre in the 3 universities. So we have the opportunity later on to talk to the individual researchers about their projects and view the posters. So we have grown over the last 2 years significantly from about 25 to over 45 researchers in the area within the centre in the 3 universities. We have received 7 million from RCUK, that's FEC, so net money is about 5.7 million. We had investment from the 3 universities of about 4 million, and then investment from industry so far of over 1.3 million. So it's a centre really of 12-13 million to date. We started off with 33 industrial partners supporting the centre and collaborating with the centre, and now we are close to 50. And of course, the objective is to expand that community and expand collaboration in the different sort of areas of the food chain. Now, we cover the whole food chain. The emphasis really initially wasn't to address agriculture so much, and not to address areas such as nutrition, but we're finding really that we are moving in those areas. As John said earlier, really it's very difficult to keep the activity within the post-farm gate sort of area. So we're finding that looking at waste and what do you do with the waste, agricultural waste as well as food waste, really you need to look at the agricultural side. So we find that really our research is moving, expanding more into those areas. We cover the research in 4 horizontal themes: food production, distribution, retail, and consumption. And we have some cross-cutting themes of energy and research and resource flows in the food chain, including waste. The interaction with the energy supply system, because you can use energy hubs to generate research that it can feed, generate energy that it can feed other areas of neighboring areas. So clustering together various manufacturing activities. So looking at that is important, and also recovering, generating power from waste heat, and then channeling that electrical power both within the manufacturing plant, but also export to neighboring facilities if that is possible, or to the national grid. So we are looking at the interactions between the food and the electrical supply system, and also looking at socioeconomic aspects and human behavior, and how that influences food choice, and then the resulting energy consumption and emissions. Okay, working with industry. I mean, the center really is very, very keen to work with industry, and we are working very effectively with industry. Both the three university groups had a reputation, and their mission really is to do research that is applied, can be applied to industry, but of course we expanded that over the last 2 years significantly. We have collaborators such as multinationals and large sort of retail players, Tesco, Marks & Spencer's, Sainsbury's, but also large manufacturers, for example, Mondelez, Kellogg's, Nestle, and so on, and also equipment manufacturers like GSL, SWEP in terms of heat exchangers, Mentor Graphics in terms of software, amongst many, many others. We fund centers using the funding provided by RCUK, so we fund projects using the funding provided by RCUK, but also funding provided directly from industry, and of course we are very keen to grow that funding and work with industry to address calls from Innovate UK, calls from DEC, and also other Research Council programs. So very active with industry support, applying to various sort of initiatives that are announced by Research Councils, Innovate UK and DEC. We're also very keen to generate IP, and we agree at the outset with our collaborators how that IP is going to be exploited. And we have a number of successes today in terms of IP generation and commercialization of the results of our research. Now, progress and highlights to date. The center has grown by activities at Harper-Adam University, sort of joining the center through the collaboration with the End-Use Energy Demand Centers call. And we have Professor Mike Theodorou there from Harper-Adams that is leading a project funded by RCUK, and that really extends a little bit into the agricultural side, sort of dealing with agricultural and food waste, and collaborating there really in looking at both the energy side, but also the use of the various sort of byproducts of anaerobic digestion and developing useful products from that. So that is an activity that is growing all the time, and of course we are looking forward to working together to both attracting funding from Innovate UK, RCUK, but also a lot of opportunities for European funding. As was mentioned by the Vice Chancellor or Deputy Vice Chancellor of Research, we have invested significantly in infrastructure in the three universities. You'll have the opportunity to view some of those facilities later in the afternoon. In the three universities, we have appointed 5 new academic staff using funding from the three universities to work in the area. And we have, over the last 2 years, managed to secure 4 million additional funding, some from RCUK, some from Innovate UK, and some from the EU to work in the area. So the center really from 13 million now has gone to 17 million in terms of funding we use to do research. And we have an extensive list of outputs in terms of publications, both journal and conference publications. You get that information from the website of the center, which is www.rciuk.org. wfoodenergy.co.uk. And also, as I mentioned earlier, IP that has been generated, and we are exploiting that with our collaborators. Now, here are some brief examples of outputs and impact. This first project here has been done with funding from DEFRA, RCUK, and also funding directly from Unilever, is to improve the efficiency of well-type cabinets or ice cream cabinets. We have developed an innovation in terms of using integrated thermal energy storage within the cabinet that achieves energy savings of 16%. Other innovations put together can achieve energy savings of over 240%. Now, this has been patented now, and we assigned the rights to Unilever, and that will be exploited by Unilever. So it's about 4 million of these cabinets are really owned by Unilever, spread around the world. So the impact is significant. A project funded primarily by Innovate UK, but also input from RCUK, looking at innovative methods of air distribution in chilled food manufacturing facilities. Within this project, we're trying to develop stratification within the large spaces, and with that, we can achieve significant energy savings. We've proven in the laboratory, we have extensive facilities here, so we've done a mock-up in the laboratory, and modeling, we have proven that we can achieve 20% energy savings compared to traditional systems. And the next step is to apply this in the factory, and we'll be doing that over the next 6 months. Another project that we'll be able to see later on is in the lab, is innovative isothermal shelves for refrigerated cabinets. And again, the projection there, that project is again funded, it's a new project funded by Innovate UK and RCUK. And we expect, again, 20% energy savings there. We haven't as yet confirmed that at control conditions in the laboratory, but the potential of that application is huge again. So we are working over the next year and a half to prove that. Again, that IP, we have patented the IP, the sort of invention, and we are exploiting that in collaboration with our collaborators, industrial collaborators. We have posters and exhibit in the labs. Food drying is a very energy-intensive process. It's used widely in the food industry. And we are working on low-pressure superheated steam drying. That has the advantage over other traditional methods of retaining the taste or improving the taste from hot air drying systems, and also retaining the nutrients. We have a mainly EU-funded project working with an Italian sort of grower and manufacturer of semi-dried tomatoes. It supplies most of the retail chains in the UK. You can see we just developed the system there, the pilot system there, to prove the concept, and we can achieve significant energy savings. We haven't got a figure as yet, but it could be up to 50%. The machine now is in Italy, tested on Italian tomatoes. We are producing another one in here, but this is an area that we're planning to do significant amounts of work. We already have collaborators, industrial collaborators from the UK in place, and we'll be looking for additional funding, mostly Innovate UK, I think, or RCUK. Apart from really developing technologies, efficient technologies, we are also working on the policy side and the modeling side, looking at the whole chain, both in terms of life cycle analysis at Manchester, but also working with UCL and Imperial and a couple of other universities on developing TEC's UK TM model. And this is a model that the government uses and intends to use to look at the various scenarios in terms of the impact of economic activity on emissions and energy consumption, and how to achieve the decarbonization targets across the various sectors of economy that Steve mentioned about earlier on. And our input really is on the food chain side. So we are working on developing on the food module of the model and providing the inputs for that for the food module. And of course, again, we're working with industry and FTF to get the data and the retail companies to get the data to fit into the model. So that's what I wanted to say. Again, thanks very much.